Web 3.0 holds the potential to revolutionize every single aspect of our online lives. One way in particular is with concert tickets and event tickets with NFTs. NFTs hold the potential to provide a much better user experience for event attendees by purchasing the tickets directly on the blockchain and holding them in their digital wallets. And so in this video, I'm going to show you how to create a blockchain-based Ticketmaster clone step-by-step from start to finish. This is an amazing project to learn the fundamentals of blockchain development, how NFTs work, and something you can also use for your portfolio if you're trying to land a highly paid Web 3.0 developer job. And you really don't have to be an expert to get started today. I'm going to show you everything as you go along. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And I put a ton of time and effort into making this tutorial for you. And the only thing that I ask in return is that you smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you like everything that you see today and you want to take the next step and change your career, break into the blockchain industry, increase your salary well past 100K, I can show you how to do that over at dappuniversity.com/bootcamp. All right, so let's take a look at the application that we're going to build together today. So this is a blockchain-based ticketing application called Ticketmaster, which of course is a nod to the world-famous Ticketmaster platform, okay, where you can purchase tickets for any type of in-person event, whether it's a concert, whether it's a sporting event. And so it's completely blockchain-based. So basically, a user just visits the website, they connect their MetaMask wallet, okay, they find the event coming up that they want to purchase tickets for. All right, they find one that has seats available. They can view the seats on a map. All right, pick where they want to sit, and they can purchase these with Ether or Ethereum cryptocurrency. And whenever they make this purchase, they'll receive a blockchain-based digital ticket for the specific event in the form of a non-fungible token or an NFT that's going to get held in their MetaMask wallet. So when they show up to the event, they'll have the NFT ticket that proves that they, made this purchase, that they have a claim on whatever seat they picked for the event. So why do this with blockchain? Well, I've made several different videos on my YouTube channel talking about the benefits of using blockchain-based event ticketing. Okay, one of the examples is a problem with the current ticketing industry. Okay, this kind of came to a head at the end of 2022 with Taylor Swift concerts, where basically all the tickets were purchased out from the pre-sale by bots and basically people who weren't their actual fans, and the actual fans were livid. Okay, and the entire industry is moving in the direction of using NFTs in some way. Okay, so basically, we've already seen this with Ticketmaster debuting NFT-gated ticket sales, starting with Avenged Sevenfold. Okay, they had a successful launch of this where basically you had to hold an NFT to purchase the ticket. Now, the ticket they received wasn't an NFT like we're going to create in our project today, but the whole idea was you had to hold an NFT in order to buy tickets to prove that you were an actual fan, not a bot. And Ticketmaster, the actual company that we're modeling today, has rolled out this feature to more artists than just the initial pilot project. And while that's not the exact use case that we're going to cover in our application today, like I was saying, the entire industry is beginning to experiment with ticketing for NFTs. It's one of the use cases that I'm most excited about for blockchain that's really yet to be tapped into. And today I'm going to show you to create this application where essentially you just purchase tickets for events with NFTs and they get held in your wallet. So let's kind of get an overview of the diagram for this project. Basically, you are going to be a user. You're going to have a MetaMask wallet that's, got some Ether in it. You can use your browser to connect to this website that we're seeing right here. Okay, this is a JavaScript application built in React.js. All right. And then you are going to essentially talk straight to the blockchain with an NFT contract. And this NFT contract is going to essentially mint each token, or in this case, each NFT to your wallet whenever you purchase it. You're going to create the tickets from scratch with this mint function, and you're going to pay money to do that. The contract will receive the Ether, and then, of course, the developer can withdraw that from the contract for getting the proceeds for the tickets. All right, so now let's go ahead and start coding out the project. So I'm going to put a link to this GitHub repository down in the description below. Okay, you're just going to copy this URL. All right, go to your terminal and then type in git clone. All right, then paste in this URL. All right, I'm not going to hit enter. I've already done this step. But once you do, you'll just see a message that says, hey, the repository was successfully cloned. All right, and then whenever you do that, you want to enter into the newly created directory. All right, after you downloaded the project with GitHub or cloned it, say cd Ticketmaster. All right. And then now we're going to install our dependencies for the project. Now, in order to do this, you need Node Version Manager. It's not Node Version Manager, Node Package Manager, okay, which comes with Node.js. Really, the initial thing that you need to install is just Node.js and MetaMask. So what is Node.js if you're not familiar? Basically, it is a tool on your computer that lets you run JavaScript. All right. So normally JavaScript, its native environment is a web browser. And so if you want to run JavaScript outside your web browser, you need Node.js installed on your computer in order to do that. All right. So you can just download the latest version here. All right. I'm using version 18. So I highly recommend you use the same version as me to ensure the best results. And then, of course, you also need MetaMask installed. You can just grab that from the Google Chrome Web Store. So anyways, you can see if you have Node already installed by doing node-v. Again, I'm using version 18.12.0. And once you verify that's installed, you're just going to do npm install. Okay. So similarly, I've already done this step. That means you're going to see basically, you're going to see a smaller message here. You'll have a more verbose message than me. It'll take longer, but you just want to make sure that all your project dependencies are installed once that's good to go. All right, so really quickly, let's just look at the other dependencies that are going to get included with the dependencies we just installed, okay? So we're going to get Solidity, the Solidity compiler for writing tests and smart contracts, okay? From Hardhat, all right? This is the smart contract development framework that we're going to use. It's going to let us write the contracts themselves, compile them, put them on a blockchain, and write tests for them, okay? We're going to get JavaScript with Node.js so we can run on our computer for React, okay, which we're going to use on the front end, all right? We're going to create the website that you see right here with React.js. And then finally, we're going to use, of course, MetaMask and then Ethers.js for connecting our project to the blockchain with JavaScript. All right, so let's go ahead and start coding out the project. All right, I've opened my code inside of Sublime Text. That's just my text editor of choice. You can use whatever text editor you'd like, but we're first going to go ahead and start coding out the Solidity smart contracts for the NFT. So if you go to your contracts directory, you're going to see a file in here called tokenmaster.sol, okay? This already has the final code solution in it. I obviously don't want to just run this, but let's go ahead and clear this thing out so we can code it out and you can see how it's going to work. So I'm going to take everything inside of here and just delete what's inside the curly braces, and we'll start off with this mostly blank slate and go from there. All right, so what we're going to do right now is start coding out this smart contract in this diagram. Again, the user is going to connect with their browser to the website. It's going to talk directly to this contract that we're about to code out together. And this is going to be an NFT that lets people mint tokens from scratch. These tokens are going to be the tickets that they use on the blockchain, okay? And then, that ETH is going to go to the developer who created it. So we're going to use the ERC 721 standard for non-fungible tokens or NFTs. So what is that? Well, ERC 721 is just a specification that says, hey, NFTs all should work about the same way, okay? So they can be supported on websites like OpenSea so that you can hold them in your MetaMask wallet, and so that we have a standard way of doing this so that everybody, is doing the same thing, that everything's compatible. So really what ERC 721 does is it defines, specific functions that you have to have on your NFTs and events, and that those functions are named the same thing, that they accept the same arguments. Basically, they have the same function signature. It's kind of the advanced way of saying that inside Solidity. And then that those functions do certain things. So like you have to have a balance of function, and that balance of function is going to return the owner, how many NFTs a specific owner has. Same thing for owner of, you should pass in a token ID. It should tell you who the owner of that NFT is. That it specifies how to transfer tokens between wallets and all that type of stuff. We'll see all these things in action as we continue coding out the project, but I just want to make a note that we are going to create an ERC 721 token for these NFTs. Now, because ERC 721 is a standard, all right, lots of ERC 721 tokens work basically the same way. We do not have to reinvent the wheel, okay? So we are going to use a library called OpenZeppelin, all right, which gives us most of the behavior and functionality of ERC 721 tokens basically for free. All right, OpenZeppelin is a really popular Solidity library where you can do things like create tokens without a ton of coding. So we're just going to get an ERC 721 library, import it into our smart contract, and then we're going to customize it, okay? So we won't have to code out a balance of function. We won't have to code out an owner of function. Okay, we'll get all this stuff for free, and then we'll create the important parts that are relevant to our ticketing process, which we can see right here. And if we go back to our code, you can see that that's really what we're doing at the state of the contract right now. This line right here, all right, it imports the OpenZeppelin library for ERC 721. All right, this is the ERC 721 library, the OpenZeppelin. This is how we import it in Solidity. So where is it coming from? Well, it's coming from our node modules directory. All right, Hardhat knows how to pull this file from our node modules directory because it's got this at OpenZeppelin. And if you have your node modules visible in your text editor, you can scroll down here. You can see, at OpenZeppelin. All right, right here. And you can see the directory at OpenZeppelin contracts. All right, you can see token, go token, and you can see ERC 721. And then you can see ERC 721.sol right here. All right. This is the file that we're importing, and you can see it's got all these functions inside of it. Like, let's look for balance of. All right. Here's the balance of function already. We don't have to code it out. We're going to import it into our contract. All right. So that's what this import statement does at the top of our file. And then in order to actually make our smart contract inherit this behavior, we do this line right here. So we create our smart contract list like this. We say contracts token master. All right, that's the arbitrary name that we've given our smart contract. But in order to inherit from this library and actually use it, we say is ERC 721. Okay. So if we don't have this, if we just do contract token master, it's not actually going to use any of the behavior that we imported from this library. We have to say is ERC 721. All right. And with that being said, we could just deploy this smart contract to a blockchain right now, and we'd have a basic ERC 721 token. All right. We have to add some additional parameters like the name, the symbol, all that type of stuff. But as is, this is pretty much a fully functional ERC 721 token. However, we want to code out the specific functionality for creating the tickets, and that's what we'll do right now. All right, so the first thing we want to do really is just create the NFT so that it has all the final necessary components to make it a complete ERC 721 token, and that's creating the name and the symbol. Because again, every single ERC 21 token has to have a name and a symbol so that you can read it from the blockchain, what the name is, what the symbol is, so you can trade it. Okay, so we're going to do that like this. Inside the ERC 721 library that we get from OpenZeppelin, it shows us that we need to create that we need to set this inside the constructor function. Okay, so let me show you how to do that right now. We can create a function inside Solidity like this called constructor. All right, and this is a special function with a special name. And what it does is it's a function that's run once and only once whenever the smart contract is created. Or said another way, whenever we put the smart contract onto the blockchain and whenever we deploy it, it's going to run this special function. Okay. And this function can have arguments just like any function inside Solidity. So what we can do is pass in the name and we can pass in the symbol. Okay. And because Solidity is a statically typed language, we must specify the data type for these. So a string, name, and then string symbol. Okay. Basically, a string is just, a collection of characters inside of, quotation marks like this. This is a string up here. A string looks like this. A string could be apple, banana, carrot. A string could be your name, Gregory, or it could be anything, any human readable text inside of quotation marks like that. So string name, string symbol. We also must tell it the location of these. We're going to say memory. All right. And then we want to pass these into the ERC 721 contract. All right. If we go back here, we can see how that works. Sorry, let's just open it. All right. You can see it takes a string, memory, name, and symbol. All right, just like we did here. So in order to pass these along to the smart contract above, we need to use a special notation inside Solidity that looks like this. If we want to pass the arguments that we're passing in here to the parent constructor, all right, the parent smart contract that we're inheriting from, well, you want to use the parent contract name right here, ERC 721. open and close parentheses. And then we want to pass in the constructor arguments that it requires. So the name and the symbol. And we'll do that like this. We'll say a name and then symbol. And these two, this name is going to get passed in here, and this symbol is going to get passed in here. Okay. Go ahead and close that so you can see it. All right. Now what I'm going to do is format this code a little bit so that it's not taking up so much space. Basically, you can use multiple lines inside Solidity like this, and I'm going to just, format the code to look a little nicer, so it's not just running off the page like that. All right. Okay, so let's save that. And now, really, we've got everything we need to create a basic ERC721 token. Okay. Now, let's check let's make sure this works. Okay, let's create a basic smoke test to make sure that we actually created the smart contract properly, that we can put it on a blockchain, and that we can read this name and symbol that we passed in the constructor. So how are we going to do that? Well, basically, we can go to the test directory. All right, so test directory, this Ticketmaster.js, okay? This is the complete test for the smart contract that we're going to create in this, this tutorial today. But we don't, obviously we want to code out these tests together. This is the final code solution. So I'm going to initialize this really quickly, and we'll set up the basics ourselves. All right, so I have cleared out my test so that we can start, writing them together. All right, so I would recommend pausing the video if you haven't done this already, and just, clearing out your test so that it looks exactly like mine. I'll give you 1 second if you want to pause the video and capture that. All right, so what we're going to do here is write tests inside of JavaScript. So testing is really important with smart contracts because it doesn't work like Web 2 development or, mobile development, where you essentially can just create smart contracts and put them out into the wild and then fix bugs as you go. Smart contract code is immutable, which means the code cannot change, out of the box. So that means it's really important to test your smart contracts so that they work properly before you put them on the blockchain. Now, testing is important in many aspects of software development, but it's particularly important with smart contracts, and that's one of the reasons I focus on it so much with Dapp University. So we're going to run our tests with Hardhat. It comes bundled with a couple of libraries that help us do this. So the Mocha testing framework, that's where you get this describe Ticketmaster function from. And then the chai assertion library, which gives us this function called expect, which is going to let us just write, tests to check for certain parameters. All right. So go ahead and make sure your tests look like this, and we'll write our first one. Okay, so the first thing we want to do is create another describe block here. All right. We're going to say describe deployment. Okay. And then we're going to put some examples inside of there that just make sure that the name and the symbol are correct. All right. And then how we write a basic test is we use the it function. All right. So we're going to say it. This is just a function that takes a couple different arguments. The first is just the test example that we're going to see in our terminal. Say sets the name. All right. And then the second argument is going to be a function. So we use an async function. And what that's going to do is it's going to run this function to check to see if the test passes or not. So what we can do is just check that the smart contract name is what we expect. So we can say expect. All right. And then I'm going to put some pseudo code in here, and we're actually going to fill it out. So we're going to say that, Ticketmaster dot name, all right, to equal, let's just see here. What do we want to call it? We'll just call it Ticketmaster. All right. So that's what a basic test looks like. It just says expect Ticketmaster name to equal Ticketmaster. All right, that's what a basic test would look like. Now, this is not going to work because we haven't actually set up the smart contract for deployment yet. All right, so we want to do that. All right, what we can do is just write that line before this. All right, so basically what we want to do is deploy the contract first and then fetch the name to make sure that it was set properly. So how do we do that? Well, inside of Hardhat with Ethers, we can just say const Ticketmaster, all right, equals await Ethers. Get contract factory, and we can pass in Ticketmaster, which is just the name of the smart contract. All right. And then we can deploy it like this. Let's see, Tokenmaster. Sorry, lowercase Tokenmaster. Say let Tokenmaster equals await Tokenmaster dot deploy. We can give it a name, Tokenmaster, and then a symbol. Let's just say, what do we want our symbol to be? Let's say just TM. All right. And then here we say expect await Tokenmaster.name. All right, let me actually do this in multiple lines. Let's just say let name equals this, and then expect name to equal Tokenmaster. So let's just run it, make sure it passes. All right, and then we'll explain the code. So you can run your test like this. You can say npx hardhat run test. I'll bump that up so you can see it better. So excuse me, that's not the correct command. I have a little bit of brain fog here. npx hardhat tests. npx hardhat run runs your scripts, and then the test command just runs the tests from your test directory. All right, so it works, it passes. It is setting the name properly. So what do we do? All right, we just have this describe Tokenmaster, describe deployment, and then one test example that says it sets the name. All right, you can even see that it sets the name, you know, right here. It sets the name and it check that test worked. It's passing. You can see one passing. We have one total test. It's just one test right here. So what we did was we just did, const Tokenmaster equals await ethers get contract factory. That's just getting the contract that we created already from Hardhat. This is a special function that comes with Hardhat and ethers, okay? And then we deploy it like this. So Tokenmaster equals await Tokenmaster.deploy. Again, this is lowercase Tokenmaster. This is the deployed contract. This is the undeployed contract. We deploy it like this, give it the Tokenmaster name and symbol. Those are the constructor arguments. So name and symbol right here. That's what it corresponds to. And then we can read the name from the blockchain like this. We just say name equals await Tokenmaster name. And then we just set the name to equal Tokenmaster. So now what we want to do is check the symbol, okay? So we want to say checks the name, and then, it sets the symbol. All right. But the problem is, we could do that like this. I mean, we could just copy this and paste it. All right. And then, symbol, let's just rename these. All right, and then set it to TM. And if we run that, it should pass, assuming that I did everything properly. Yeah, 2 passes, sets the name symbol. But this is duplication in our code. We don't want that. So how do we reduce the duplication? Well, we can use something called a before each function, which basically lets us run common code before certain test examples. So before this describe deployment, I'm going to use this function called before each. That's going to accept a callback function. All right. And then that's going to let us run this code. All right. Before each test example. So we can take this out. All right. And I'm going to put this like this. And then I'm going to declare the variables up here. Say let Tokenmaster. All right. Take this off. Okay. And then now that should work. Let's just run it. All right, still passes. And now we can see we've reduced the duplication in our code. We can also clean this up a little more. We don't have to keep these as separate variables. We can make this a one line. So we can just take this out, put it here. I just made it separate variables so that you can see what's happening a lot easier. All right, save that and then run the tests. And boom, it still passes. Okay, so we have checked the basics of our smart contract. We've created an NFT that's got a name and a symbol, and boom, we've got a fully fledged ERC-721 token. Now, it doesn't exactly do everything we want to do in terms of the ticketing. We're going to code that out in a minute. But we have this working. We've got our testing process set up. I want to do a couple of things here just to optimize our tests. And one more change in the smart contract before we move on, okay? So I'm going to refactor the name and symbol up here as variables. So we'll just do const name, capital, and const symbol, all caps. And then we're going to, do this. We're going to put in the name here and then put in the symbol here. We'll replace those. and then we can reference these variables later. This is, basically drying up our code, which stands for don't repeat yourself. Dry is a software principle. Don't repeat yourself if you don't have to. It makes your code much easier to maintain, easier to read, all that type of stuff. All right, let's run the tests. And they pass. Now, we also want to do one other quick thing, okay? We want to set up the accounts. So we're gonna have a couple different scenarios in this. We're gonna have a developer, all right, who receives the Ether for the tickets, all right? We're also gonna have a user who buys the NFTs. And so we're gonna reference those people throughout our testing scenario, all right? So we wanna create them at the top. So right here, we have, let Tokenmaster. We're also gonna create some accounts here. So let deployer and let buyer. So this will be the deployer and this will be the buyer, all right? And we're gonna model those people inside of here with Ethereum addresses or signers. And what we're going to do is use a function inside Ethers.js that lets us pull those accounts out. So we'll say await Ethers get signers. So signers are a concept in Ethers, which basically just represents a user on the blockchain that can sign transactions. It's not an address itself. It's a key pair with a lot of other functionality associated with it. You can get the address, you can get the private key, you can get all that type of stuff. But that's how you do it. Now, this returns an array, all right? And what we can do is we can reference each item in this array, or each signer, with parallel assignment. So basically, we can just save the buyer and the deployer like this. Basically say deployer buyer equals await Ethers get signers. We save them to these variables, and now we can reference the deployer and the buyer throughout the rest of our test examples. Now, why did I do this now and not later? Because finally, we want to add one little piece of functionality to our smart contract, which is to save this developer right here, okay? So we're going to do that inside of our smart contract like this. We're going to create an owner variable at the top, okay? So let me show you how that works. So basically, we're going to create a variable, all right, up here. It says address public owner. That's going to be the owner of the smart contract, the person who has all the permissions to do things with the smart contracts, like get the money. That's going to be this person right here. And we just create a state variable, which gets saved to the blockchain like this. It's an address. It's public, so we can read that information outside the smart contract with Solidity. Solidity is going to be a special function to read this owner variable value. We make it public. And then we can just save the owner inside the constructor function like this. We say owner equals message.sender. So what does that mean? So message is a global variable inside of Solidity, all right, with multiple different values that you can access. One of them is sender. So message.sender is the address of the person who is calling this specific function right here, or the person who is calling any function. In this case, it's just the constructor function. So we're going to say owner equals message sender. We'll save that right here. It'll get written to the blockchain, and we can read it from the blockchain with the owner function because this variable is public. So what's that look like on our test? Well, we went ahead and, got the deployer address here, okay? And so we can just create a new test example that says, hey, it sets the owner, all right? And then inside of that, what we can do is basically say expect await tokenmaster.owner. Again, that's this function that's exposed by Solidity when we made this public, is equal to the deployer.address. Okay, this deployer right here, and then you call .address. Okay, you have to call .address. That's not going to work. It's going to return the entire signer object, say address. Let's save that, run the tests, and boom, 3 are passing. Okay, so I want to show you this gotcha. This is something that's pretty common inside, testing with Hardhat. People forget to do this all the time. If I do just deployer and run it, it's going to fail. You can see expected this to equal signer with address. That's because you have to call .address here. All right, but if I save that, then boom, it passes. All right, so now what we're going to do is code out this functionality to create different events that people can purchase tickets for. So this is the mock-up of our final application. I'll revisit this through the rest of our session here. But you can see, for example, like here's an event on May 31st. This is UFC Miami. It's sold out. Or, on June 2nd, ETH Tokyo. You can view the seats and purchase the events. these are different events, all right, that you can buy tickets for. And now what we want to do is create a way to create these events inside the smart contracts and store them on the blockchain so that the tickets can be referenced for each of these events. So inside of the Solidity smart contract, we're going to create a new function to do this. All right, a new function. That's the function. That's the keyword that we use to create a named function inside Solidity. And then we give it the name, which is list. All right, and then we can write all the code for this inside of these, curly braces, like step 1, step 2, step 3, on multiple lines. Okay. So with this list function, we want to make it public. All right, and this public visibility basically just means that this function can be called outside the smart contract, from our app, for example. If we didn't put this on our function, our app would not be able to call this list function. All right. So what this function is going to do is, create a new event, and it's going to have a name, a cost, and some other settings like the date, the time, location. All right. And we're going to pass those in as function arguments. So we can say the string memory, all right, name. All right, and what I'm going to do is break these up into multiple lines and list out all of the function arguments right here. All right, so here's all of the arguments that we're going to have. An event can have a name. All right, that's what you see like right here, like UFC Miami. All right, it can have a cost. All right, which you can see right here. It's like 1 ETH. Okay, it's going to have the max number of tickets that can be sold for an event, right? So if you click on the view seats, let's say there's 100 seats, then you can only have 100 tickets, all right? The string for the date, that's going to be the actual calendar date, which is right here, like June 9th. And then the time is a separate argument, which is like, 10 a.m. TRT or 2:30 p.m. Central Standard Time, which you can see right here. And then location, of course, is going to be, American Airlines Center, Dallas, Texas, for example. All right, so inside this list function, we need a way to model the events themselves, okay? So we're going to use something in Solidity called a struct. So a struct is something you can create like this, struct, my struct, I'll choose this name. And Solidity is a statically typed language, but we can create our own data types with structs, which basically are just these kind of like objects that you can give arbitrary parameters. Now, we want to create one of those inside this list function, all right, to model the event. And now, normally in an application, I would use terminology that corresponds to the exact same thing that we're creating here. These are events that we're seeing on our page. So normally I would say like a struct event. But that's not going to work because this is going to have a naming conflict inside Solidity. All right. So Solidity has events in the code. All right. You can see like, this keyword right here, event transfer, event approval. So this is a reserved keyword inside Solidity, and we're not going to have something called event inside of our smart contract. So we'll use a different word that kind of means the same thing. We'll call it an occasion. Okay. So struct occasion, this is, the keyword in Solidity, create a struct. We're just going to call it occasion just to have our arbitrary name here. And then we can give it all these different parameters like this, okay? We can give it an ID, a name, a cost, the tickets, the max tickets, the date, time, location, which is really just going to correspond to the arguments that we're passing in to our list function right here, okay? Now, this simply defines the struct. This has not created any type of occasion. This just tells us what the, what the ingredients for an occasion are, or the different attributes that belong to an occasion. In order to create an occasion, we're going to do that inside of our, list function like this. There's an occasion. All right, you can create a new event just like this. You want to follow by a semicolon. All right, you need a semicolon for each line inside your function inside Solidity. And then we can just pass in all of the attributes, like ID, name, cost, symbol. So for ID right now, we're just going to hard code the ID of 1. We'll change that in a minute. And then we'll pass in these other ones like this, like name, and then cost, and then max tickets, and then the date. Actually, let's see. We need name, cost, the tickets, and then max tickets. All right, date, time, occasion. So I'm just going to copy these and let's put them on new lines here. Let's just do this. All right. So for now, we're just gonna make it look like this. So occasion, ID 1, name, cost, max tickets. We'll just pass in max tickets again, the date, time, and location. All right, and that's gonna create a new occasion. All right. So this defines the occasion. This creates the occasion inside of the list function. Okay. Now let's talk about how to compute the ID. So each struct occasion is going to have a unique identifier. Okay, like 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what this uint is inside Solidity. This stands for unsigned integer, which basically is just a number that's not negative. All right. And we can create the IDs, dynamically with something called a counter cache. All right. So what we're going to do is at the top of our contract, we're going to create this variable here called total occasions. All right, this is going to be the occasions count or total occasions. So we say uint 256. Again, this is a number that's not negative, public total occasions. And inside of this function, what we can do is every time we call it, we can just add 1 to that number. So when we start off, it's going to be 0, okay? So that Solidity knows it's going to be 0, but it's going to start off as 0. That's explicit. This is implicit. And what we can do is just say occasions equals occasions plus 1. We can add 1 every time we call this function to use our counter cache to increment the ID. All right. And then actually that wouldn't be occasions. It would be total occasions. Sorry. All right. And then we would just do total occasions here. Okay. And then that's basically going to be our ID whenever we create a new one. Every time we call this function, we'll just add 1. It's just going to start off with 0. So the first time we call this function will be 1. Second time it'll be 2, 3, 4, 5, 6, 7. And then that number is going to get updated and stored right here on the blockchain. Okay. Now, the last thing I want to show you is that you can simplify this line. You don't have to do total occasions equals total occasions plus 1. There's a shortcut inside Solidity that looks like this. Okay, so this is called the increment operator, which basically takes a number you call plus plus after it, and that just adds 1 to the previous value and saves it. It'll automatically update it and save it on the blockchain right here. Okay. All right, so the next thing we want to do is actually save this occasion to the blockchain. So inside of our list function, we're passing in all these attributes for the occasion. We're creating one right here, okay? We're not actually saving it to the blockchain. All we've done is instantiated an occasion in memory inside of our function. We actually want to write to storage and put it on the blockchain. So how do we do that? Well, we need a special place to put it, all right? And so we're going to use a mapping for that, okay? So I'll show you that right now. At the top of our file here, we're going to use the mapping keyword, say mapping. Say uint 256. Okay. And then we'll say occasion. Say public. Actually, we're not going to do public. We'll say occasions. All right. So let me explain what this is. So what's a mapping? Well, a mapping is a place where you can store key value pairs. So what is a key value pair? So you can see a simple example here of a key value pair where you have a key, which acts like a unique identifier, and it corresponds to one and only one value. So for example, a key is first name and then value is bugs. And, for example, this person doesn't have more than one first name. It's only one first name. The key is first name, and then the value is bugs. Last name, one and only one last name. So the key is last name, and the value is bunny. Location, only one location at a time. And the value is earth. Okay. So we can use key value pairs like that. We can also use them like traditional databases, where traditional databases have IDs. So an ID is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the value is the record, okay, that it corresponds to. So that's similarly what we're doing right here. We're creating a mapping, which is just this key value pair. The key is a number, so an unsigned integer of the ID that we're doing right here. So ID like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the value is going to be an occasion struct that we are saving to the blockchain. And then we just give our mapping a variable name, which is going to be occasions right here, all right? So right here, we have simply just defined the mapping. We haven't actually added anything to it yet. There's nothing in it. Just like we defined the struct here, we had to create one. So inside of our function, we need to use this mapping we just created to add the struct to it. All right. So we'll do that like this. Basically, we can do it several ways. We could say, we could save this to a variable, but I'm just going to do it shorthand like this. You write stuff to a mapping like this. Basically, you say occasions, which is the name of the mapping. You use open close brackets. You give it the key. So it's going to be total occasions. And then you assign the value, which would be, the occasion. All right. And then you would put in all the stuff that you've created right here. Okay, that's all this stuff right here, but I'm just putting pseudocode for now. So that's the name of the mapping. Use the brackets for assignment. You pass in the ID, which is the number right here that we created. And then you give it the value, which is the newly created occasion. All right. So I'm just going to backspace this thing right here and put it right here so that you can see it easier. I'm just going to backspace this, and then that's what it would look like. So occasions equals total occasions equals occasion, and then you pass in all the attributes, and now it is going to be saved to the blockchain. And there you have it. That is our list function, okay? And really quick while I'm looking here, I realize it needs an S, so I'm gonna add that. That's my fault, everybody. Okay, and so now let's write a basic test to make sure this works. We're gonna go to Ticketmaster.js, and we're gonna create a new section, all right, called occasions. So we're going to say, we've already described the deployment, so we're going to minimize that in our text editor. We're going to create describe occasions, all right? We're going to close that out here. And we're going to say, it updates the occasions count. All right, that's the first thing that we're going to do. We're just going to run this, make sure that it basically works. And so what we're going to do is say const total occasions equals await token master total occasions. All right, that is this total occasions right here. And then we should expect total occasions to be equal 1. All right, whenever we created it, we need to make sure that it's 1. Now, we haven't actually created an occasion yet, so let's do that. All right. Let's do it in our before each function. We're going to say await token master connect deployer. And I'm going to call this list function that we just created. Okay, we're going to pass in the arguments in a minute, but let me talk about this. So token master is, of course, the contract that we've created here. And we need to use this connect function right here. So what is that? Well, we are doing a transaction on the blockchain, okay? And we need to specify the account that we're doing that transaction with. In this case, it's the deployer, okay? The deployer is this character right here in our scenario, the developer who's creating the contract. That's who's going to get the ETH. And essentially, we want to make sure that they are signing this transaction. So the way Ethers works is we must specify the signer. This is the signer from get signers, okay? So we do token master connect deployer, and we're going to call this list function right here. Now, we need to give it all of the variables that they're going to get passed into this constructor function right here, okay? So let's see what those are going to be. And we're going to save them to the top of our file. So what I'm going to do is put those right here. All right. So it's a const occasion time equals ETH, occasion name is ETH Texas. All right. Occasion cost will be this, be 1 Ether. All right. The occasion max tickets will be 100. Occasion date will be April 27th. Occasion time will be 10 a.m. CST. And then occasion location will be Austin, Texas. So if you want to pause the video and copy those down, or you can grab them from the final code solution, just copy and paste. All right. And so now I'm going to add those to our list function like this. All right. I'm just going to take this away and put it in list right here. I'm going to pass in the occasion name, the cost, the max tickets, the date, time, location. All right. And then finally, we're going to save this to a transaction, say const transaction equals await. And then we're going to say await transaction wait. So basically, this is the function call. It's going to return a transaction. And we want to wait for this transaction to get included into a block before we test for it, okay? Because this will basically send the transaction to the mempool, okay? But if we call this function before it's actually included into a block, this test may not pass. So what we want to do is wait for the transaction to get included into a block and then run this test, okay? So let's save that, see if it passes, make sure I didn't miss anything. Can't guarantee that. Let's just see if it works. Okay, so I did make an error, looks like, in my Solidity smart contract. I'm not perfect, and honestly, I like leaving these errors on the video because it shows you that I'm not perfect. You know, no developer is, and you have to troubleshoot your way through these types of things. It's part of being a developer. This is real life here. So I'm just going to intelligently read this error message. So inside your contracts file on line 21, that's what this is, the mapping occasion, this right here. So identifier not found or not unique. So what I'm going to do is go up here, occasion, and it's not the same name. I've got a typo. So I've got two S's in there, occasion. Sorry, everybody. You might have caught that before me. Good job if you did. All right, now it passes. So it properly updates the occasion count. All right, so now we have successfully tested that we have created an occasion, right? We just saw that the count changed by 1, that now the total occasions is 1, the occasion was successfully created. But now what we want to do is actually test to see that the occasion was created with the right information, okay? That the name that we passed in is correct, that the time is correct, all that type of stuff, okay? And so let's talk about how to do that, okay? So I want to create a special function, all right, inside of here. Let's just see here. Inside of our Solidity smart contract, it's going to look like this. I'm just going to toss it in there and you'll see how it works. Say function get occasion. So this is going to be a reader function. So it's going to be public view, and it's going to return the actual occasion itself. And so inside of this, we're just going to pass in the ID, and we're going to read the occasion from the occasions mapping. So here's how we wrote occasions to the blockchain. We just did the occasions mapping. We used open and close curly braces, passed in the key, and then we assigned it with the assignment operator. That's the equal sign. But we can just read the information for the blockchain just by giving it the mapping name, giving the ID, and no assignment after it will simply return the occasion record for us. And then we can use the return keyword in our function to expose that to our application because it's public. And then we specify the return value is an occasion struct from memory, okay? All right, and now instead of our test, we're gonna create a new test example in this block right here that updates this and actually checks for the attributes. So I'm just gonna throw that in there. I'll explain it. You can pause the video or grab this from the final code solution if you want to do that. Okay, so what we're gonna do is say const occasion equals await token master get occasion, and then passing the ID of 1. Okay, that's this function we just created, get occasion. It accepts an ID of 1. We know that 1 was just created, so we can use the ID 1. And then we can say expect occasion.id to be equal 1, expect the name to equal this occasion name that we set up here. Okay, that's why I use these variables, so it's easy to check stuff. All right, same thing for the cost, same thing for max tickets, the date, the time, and the location. All right, so now let's run the test, see if it passes. All right, and boom, it works. So we're almost finished with the functionality for listing out these events on the page, like you see right here, these different occasions. But there's one problem with our smart contract as it is, okay? At this point, anybody can create a new event on our Ticketmaster smart contract or our Token Master smart contract, okay? But really, what we want to do is only the developer who's getting the money for these events, only that person should be able to, create an occasion. So we can use a special function inside Solidity called require, all right? So what we can do is inside of here, we can say require, all right? And this is a function that basically is going to check for a value. It's going to check that an expression returns true, okay? And if the expression returns true, then everything inside this code is going to run just fine. But if the expression evaluates to false, okay, then none of these lines are going to run and the transaction is going to get reverted and like nothing's even going to happen on the blockchain. Okay, so this is basically a check that says, hey, require that something is true before you do all this type of stuff. So what do I mean by expression evaluating true? Well, you could be, right, make sure that 1 plus 1 equals 2, all right? And of course, 1 plus 1 does equal 2, and therefore this code's going to run, okay? But if you said require 1 plus 1 is 3, this is always going to evaluate to false, mathematically speaking, and these lines will never run, right? You can do arbitrary things inside of here, like require name equals Jim or something like that, right? But what we're really going to do is make sure that the owner of this contract is the one calling this function so that nobody else can add these occasions. So we do that like this. Basically, require message.sender is equal to the owner, all right? So what is that? Well, the owner, again, is this address that we saved as a state variable, and we assigned it here with message sender inside of our constructor function. So in the constructor, message sender is the person calling the function, right? That's what message.sender is. It's a globally available variable inside Solidity. Sender is just the address of the person calling the function, and we assign it to the owner here. Likewise, we just want to make sure that this person is the same as the owner. So message sender is the person calling the function. We want to make sure it's equal to the owner. All right, and one more tidbit is this single equal sign is assignment. This is saying make the owner equal to this person. This one is just evaluating whether the message sender is the same as owner. So this is assignment. This is checking for equality. Those are different things. 1 equal sign, 2 equal signs. So make sure that person calling the function is the same as the owner address, which is saved here. All right. So now we can save this, rerun our tests, and it still passes. Now, I'm not going to create a special test for this. You can do that as an exercise if you like. I just want to make sure that this is in there. Now, finally, I want to clean this up. We can refactor this a little bit because, we want to have some other functions that only the owner can call. Like we're going to have a function that lets the owner withdraw the ether from the smart contract. Okay. So we'll get to that later. But what we're going to do is move this into something called a modifier inside Solidity so that we don't actually have to have this inside of our function body. So a modifier is basically just something that lets us change the behavior of a function. I'll show you how that works. So basically, I'm going to create this modifier up here. All right. Just below this mapping, I'm going to say modifier equals only owner. Okay. And inside of here, I'm just going to copy this line or cut it. Okay. I'm going to paste it. Okay. So require message.sender is equal to the owner. And then I'm going to put this underscore here. And then we can copy this and just apply it to our function. So we can say public only owner. That's what a modifier is. Basically, it's this special code that we can add to our function like this that's going to run before all this other code. Okay. Now, it's going to run before the other code because we use this underscore after this require function. So what is underscore? This underscore corresponds to the function body. So this is the function body. This is all the other code inside the function. So for example, if we did it here, we would require that the owner is message sender after. Doesn't really make sense because we want to check it before. And if it fails, we want to stop there. So basically we're saying, hey, run this before you run all the function. And then we just copy this and then put it here. And that's automatically going to be applied to our list function. All right. So we can check it still works. Go to our tests and it still passes. Awesome. All right. So now what we're going to do is create the functionality to let people buy tickets. Okay, so going back to our mockup, we've now created the way to create events, or occasions in this case, like these different events that you might want to buy tickets for. And then, we're going to click this button when we create the front end that says view the seats, and then you can click on a seat, and then you can purchase the seat at ticket cost, so like 1 ether, for example. Okay, so we're going to create a new function inside of here that's basically going to just mint the NFTs. So going back to our diagram, when the user connects to our application, they're going to buy the NFT, which is going to call the mint function. Okay, so the mint function is going to create the tickets or the NFTs from scratch, okay, like 1, 2, 3, and it's going to send them to their wallet. And of course, the developer can get paid for doing this. All right, so inside of the smart contract here, just below the list function, all right, we're going to create a mint function. So we'll create a function like this, function called mint, all right, let's be public, and then inside of here, we're going to mint the NFTs. Now, we're not going to code out all the behavior from this from scratch because, again, we're using this library from OpenZeppelin, all right? And OpenZeppelin has a mint function already, okay? You can see it. It has a function called mint and then safe mint and then all that type of stuff, okay? So what we're going to do is use this safe mint function inside of our function to get this behavior, and then we'll write all of our custom behavior on top of it. All right. So we've already got this because we've inherited from this library right here. But inside this mint function, what we can do is just call the safe mint function like this. All right. And then pass in the arguments that is needed to create the NFT from scratch. All right. So what arguments does this safe mint function take? Well, you can use this one right here. It's going to take the address of the person who's going to receive the NFT and the ID of the token, all right, that's created in this case, okay? So for the safe mint, what we can do is basically pass in the owner wallet of the person, sorry, not the owner wallet, the address of the person who's calling the function, which in this case is message.sender, all right? And in terms of the ID, all right, we must compute the ID. So we basically created a counter cache in our list function for the occasions to, store how many occasions exist, all right? And then we, wrote them to the mapping like this. We can do a similar type of thing in our contract by creating a total supply counter cache. So just below total occasions, we could say UN256 public total supply, all right? And that's going to be the number of NFTs that exist. So total supply is the total number of NFTs, all right? And we'll use that as our ID scheme. So just like we incremented the total occasions, all right, we'll do the same thing here. We'll just say total supply plus plus, all right, and we'll pass in the total supply here, which will be the new ID, all right? So anytime somebody calls this function, we'll add 1 to the total supply. Whenever it starts off, it's going to be 0. So the first time somebody calls this function, it'll go from 0 to 1, all right? And then basically the safe mint function will be called, and it'll create an NFT with the ID of 1, and it will assign it to the wallet of the person who is calling this function, okay? Now, that's the basic functionality for minting. Like, we could just leave it there, and then people would just be minting NFTs to their wallet. Now, it wouldn't be very useful because these NFTs, would not really correspond to, it would not correspond to any of the different tickets, okay? But you would at least have an NFT. It wouldn't have any special data. It would just have an NFT with an ID. So we need to add some behavior. The first thing we want to do is make sure the developer is going to get paid, okay? So what we can do is make this public payable, all right? What that's going to do is let somebody send in Ethereum cryptocurrency or Ether with this function call, where they call this. They can say, okay, call the mint function, but also send in the money that's required to purchase the NFT. That's going to be this cost, okay? And then so they'll send in Ethereum cryptocurrency, which will get stored in the smart contract, and we're going to let the developer withdraw it later. But we must have this payable modifier on our function so that someone can send in cryptocurrency whenever this function is called, okay? So that's the basic functionality. Now we need to add several things to it, all right? Let's start off with essentially assigning this to different occasions. All right, we need to make sure we're buying NFTs for the right event, essentially, or occasion in this case, and then also for the correct seat. So let's do those things one by one. All right, so first thing we want to do is make our function aware of the event or occasion that they are purchasing the ticket for, and then which seat they are getting. Because again, with our mockup, they want to click on the event and then, view the seat. All right, this is not actually going to work because I I turned the project off. But basically, they're going to click that. They're going to see different seats. They're going to click the seat. And, they're going to be able to specify which seat they want. So first of all, it needs to be aware of the event. So we can say uint ID. This is going to be the occasion ID. So are they buying tickets for the UFC thing or, a concert? Say uint 256, long way. And then we're going to have the seat number, uint 256, and then seat. So this is the occasion ID and then the seat number. Okay. And so the first thing we want to do is whenever someone purchases a ticket, we want to reduce the number of tickets that are going to be available going forward. Because if you buy a ticket and there's only 100 available, whenever you purchase this, well, now there's 99 available. And then subsequently 98, 97, 96. And if you remember, on our occasion struct, we have a max tickets, all right? Whichever we create our last one, say it's 100, it got safe here as 100, okay? And so we're going to decrease that value. So basically what we're going to do, we're going to fetch the occasion from the mapping, say occasions. We're going to pass in the ID, which comes from here, all right? And we're going to see the number of tickets, all right, that are available, all right? And let's say it's 100 in this case. Well, now we want to do is subtract one ticket. So we can do that like this, minus equals 1. And what that's going to do is update the ticket count and take 1 away. All right, so whatever they call this function, let's say there's 100 tickets available. This line is going to take 1 ticket out of availability. So whenever this function's done, now only 99 will be available so that whenever someone calls this function, like we won't have run out of tickets, okay? Okay, so next we want to do is make sure that whenever the person, buys the ticket, that the seat is no longer available. So this decreases the number of tickets available, but we want to be specific about which seat was actually taken. Okay, so we've got a seat number in here. So we can use a mapping for this. So up here in our mappings section, what I'm going to do is create a new mapping like this. It says mapping uint 256 equals, it corresponds to the value of mapping uint 256 address and call it public seat taken. Now, this is more advanced than the mapping that we created before because it is a nested mapping. So what do I mean by that? Well, this right here is going to be the ID of, the occasion, okay? And then this right here is going to be the ID. So that's going to return a mapping in and of itself. So the key is the occasion ID, and the mapping is going to be a mapping of all the seats with the ID and the address on whether or not the seat is taken, all right? And it's going to tell us the address on who the seat is taken, by. So basically, here's the occasion, here's the seat number, here's who the seat belongs to. All right, that's going to be the seat taken, okay? So that tells you which seat that you're going to have access to whenever you buy this NFT. So then what we can do is just assign that, all right, below this, like this. Basically, we can say seat taken, ID of the occasion, which is passed in here, the seat number that's getting taken in, and we can assign that to message.sender, the person calling the function. That's just going to assign the seat to them. All right. And then what we want to do is set up an array, okay, that's going to keep track of all the taken seats to make sure that nobody else can buy this seat in the future, okay? So we're going to create an array at the top of our file like this. Go up here and just below, actually, no, it's not going to be, it is going to be an array, but it's going to be inside of a mapping like this. So mapping, uint 256, the ID of the occasion, and then the seats that have already been taken, okay? So we're going to call that seats taken. So an array is just a collection of items inside curly brackets like this, so apple, banana, carrot, all right? It's going to be an array like this of unsigned integers, which is going to be the numbers of the seats that were taken, okay? And so then we can basically just add those here with the push function. So just below the seat taken ID, we do this, seat taken ID, that's going to return the array. We do push, which just adds an element to the array, and we just push in the seat number. So basically that just updates the seat that is currently taken. All right. Now there's one last thing that we want to do is we want to make sure that the NFT is not purchased twice. We want to keep track of who has purchased this particular NFT for this ticket before. So we're going to create a final mapping here. We're going to be done with our mappings after this. That basically is just a mapping on whether someone's bought already. Okay. So just below this, we'll create a mapping. That's the unsigned energy of the occasion. And then the mapping of the address of the person buying it and a Boolean, which is just a true or false value to see if they have bought. Okay. And so then I'm going to scroll down here and we're going to actually use that right here. And then just above this, we'll say has bought, ID. That's going to be for the occasion. And then message.sender is the person calling the function. And we're just going to say is equal to true. All right. And so now we've basically done all this. We've got the occasion. We have created the decreased number of tickets. We've updated the buying status. We've marked the seat as taken. We've given it the address of the person who's taken it. We've kept an array of all the IDs of the taken seats. We've increased total supply, and we've minted them the NFT. Now, that's all the basic functionality that we're going to need in order to run this. We're going to add some stuff to this function here in a minute, but I want to go ahead and write some tests just to make sure that this is working properly. Okay, so now let's write some tests to make sure that this actually works as we expect, okay? So I'm going to go into my Tokenmaster.js file, okay? And I'm going to scroll down here. I've got the deployment minimized. You can see that here. I'm going to go ahead and minimize the occasions description. And then I'm going to create a new one here that says describe minting. Okay. And we're going to close that out right here. Okay. And so inside of here, what I'm going to do is, let's just see here. We're going to do a before each function to set up our minting. Okay. And then we're going to add some variables to this that we're going to pass into our function that we'll read later in the tests. Say const ID equals 1. So this will be the first NFT. We'll say, the first occasion. The const seat will be seat number 50, just an arbitrary number between 1 and 100. And the amount is going to be the cost of the ticket. So we're going to use 1 ether here. So amount equals ethers utils parse units 1 ether. All right. And then we're going to reference those variables inside of here. Basically, we're going to do this. So let me zoom out so you can see this. Const transaction equals await token master connect buyer. So again, up here we connected to the deployer account. Okay. But here we want to connect to the buyer account because in this case, it's going to be the buyer who's connecting their wallet and then buying the NFT. All right. We do token master connect buyer. We call the mint function. That's what we just coded out here inside the smart contract, this mint function. We pass in the ID and the seat, just like this. The ID and the seat, which come from this ID and seat. Now, in terms of the cost of the ticket, again, this is going to be paid with Ether or Ethereum cryptocurrency. And this function is payable, okay? So we're not going to pass in the cost with a function argument like this. We're going to pass it in with function metadata. Okay, so you put metadata inside these curly brackets. So like here's the regular arguments. So a function can take lots of different metadata. So you just do a comma, and then you put the metadata inside these curly brackets like this. And the metadata in this case is value, okay? The value is the amount of cryptocurrency that we're sending in terms of Ether. And we just say the value is the amount, which is 1 Ether, okay? So then we want to create a simple test that just makes sure that we're updating the ticket count, okay? So basically, whenever we do the occasion, we're going to get the occasion and make sure that the ticket count has decreased by the maximum number from 1. Okay. So we'll do that like this. So it updates the ticket count. All right. So we say const occasion equals await token master get occasion 1, just like we did up here. All right. We did get occasion number 1. All right. And we're going to check on this line right here. So the occasions ID tickets, we took 1 away. We update the ticket account. We just want to make sure in our test that the original ticket account, which is the max tickets, which we set way up here, which was 100, okay? We want to make sure that it is that number minus 1. So really it's 99. You can even play that in the test. I'll show you in a minute. Let's just run it and see if it passes. Make sure I didn't make any errors in my coding. Probably did. All right. I didn't, so I'm actually surprised. but it does update the ticket account. It passes. So you could even change this to 99. All right, and then run the test again. It still passes. You can change to 98 to make sure that it's actually working. It fails. Okay, so you can see on the failure, it expected it to be 98, but it got 99, so it's working. All right. Now I want to add in some more, functions here to make sure that this works properly, or some test examples, I should say. We're going to check the buying status like this. So you could just copy this from the final test example if you want to. Basically, Ticketmaster has bought ID buyer.address. That's going to just read that from the mapping. So we're checking the buying status here. Has bought. All right. Run that test. Okay. We're going to check that the seat is taken. Oops, sorry, that's the wrong one. Or that's the buying status. We went to the seat status. Like this. So await Ticketmaster seat taken. All right. Run that test. Make sure it passes. Again, you can grab these from the final code solution if you want to. I'm just going to test them quickly so we can move on to the other parts. Now, in order to do the next thing, we need to add another function to our contract. We want to get the overall seats taken. So we're going to add a function down here that just gets all of the seats taken and then reads it out from an ID. So just above below get occasion, we're going to get this new function called get seats taken. We're going to pass in the ID, and it's just going to read the true or false status from the array. Okay. So you can grab that from the final code solution if you want to, but that's basically what it does. It just returns this. Okay. So inside the test, we'll check for that like this. We'll say updates overall seating status. We're going to just get the seats taken, passing the ID. All right, it's going to return an array. We'll make sure that array length is equal to 1 and that the first element is equal to the seat ID. All right. And then we'll run the tests. All right, passes. And then finally, we want to check that whenever they sent the money in with the transaction that is currently stored in the smart contract. Like this. So updates the contract balance. Basically, we just check the balance of the contract like this. Await Ethers provider get balance Ticketmaster.address and make sure the balance is equal to the amount. And boom, it passes. Okay, so we've done most of the work on the minting function. However, we want to add some functionality so that we don't have problems. Okay, so for example, we're passing in the IDs in the seat here. We want to add some safeguards to make sure that it's valid information. So they're not like buying seats twice, that they're buying the correct seats. Okay. So the first thing we want to do is use these require functions, just like we did up here with only owner, right? Require the message.sender equals only owner. We want to do things like, add some more requires here. Okay. And we want to pass in, for example, we want to check this, make sure this ID is valid. So the first thing is like, we want to make sure that the ID is not 0 because we're never going to have a occasion number 0. All right, so we can check that, run the test and make sure it still passes. I'm not going to write specific test examples from this. You could do that as an exercise if you'd like. I'm just going to add them in here and show you that it works. Okay. And we also want to make sure that the ID is less than or equal to the total occasions. We don't want them, basically, if there's only 10 occasions, we don't want them to pass in ID number 99 because that's not going to be a real occasion that they can purchase tickets for. Okay. So I'll do that and then add this comment here to explain this code. All right, then we'll run the test. All right, so it passes. Now next, we want to make sure that the amount of cryptocurrency they're sending in is the correct amount. Just do it like this. So basically, we'll say require message.value is greater than or equal to the cost of the occasion. So let me explain that. So message.value right here is the amount of cryptocurrency that's getting sent in with the transaction. So you can see message.sender, again, this is the same globally available variable inside Solidity, message or MSG, okay? And then we could call .sender to see who's calling the function, but we can also call .value to see how much cryptocurrency is getting sent in with the transaction, okay? You can even see that here. We specified value in the function metadata with the amount. Well, now that's in JavaScript. So in Solidity, we can read that value that's sent in with the function metadata right here with message.value, okay? And what we're doing is making sure that it's greater than or equal to, it's at least the cost of the occasion, which is stored, right here, all right, on the occasion struct. We just read the occasion struct out of the occasions mapping, the ID, and we get the cost and make sure that the amount of cryptocurrency that are getting sent in is greater than or equal to that amount, all right? Save that, run the tests. Still passes, all right? And then finally, we want to require that the seat is not taken and that it actually exists, okay? So we'll do that final check right here. Basically, we'll just say, make sure that the seat taken, ID in the seat, is not equal to the address 0, okay? And then also that the seat is less than the max tickets. Okay, so you've already made sure that it's a valid seat amount, but if there's only like 100 seats, we don't want to, look at, number 150 or something like that, okay? So let's save that, run the test, and it passes. All right, so we are almost finished with the code for our smart contract. Okay, we've got the ability to, list events or occasions that people can purchase tickets for. We've got the ability to purchase tickets right here. We've got tests for all this stuff. The last thing we want to do is make sure that the developer who created this contract can get paid. Okay, so let me explain what I mean. Right now, whenever someone buys a ticket, the money that they're sending in with Ether is getting stored into the smart contract itself. Okay, it's not actually going directly to the developer, all right? But what we're going to do is let the developer withdraw the money from the smart contract to their wallet whenever they want to, and only the developer, not somebody else, okay? So you can see in our test, whenever we checked the minting functionality, the last thing we checked for is that it updates the contract balance. So you can see the balance equals await Ethers provider get balance token master, which is the contract address, that it's equal to the amount of cryptocurrency getting sent in. So our tests know that the Ether is currently held in the smart contract. Now we want to create a function to get the Ether out to their wallet and then run a test for that, okay? So it's pretty easy. We're just going to create one final function here. I'm just going to drop this in here. You can grab it from the final code solution if you want to, or you can copy it down by pausing the video right now. Okay. So we have a function called withdraw. It's a public function. That means it can get called outside the smart contract, but we apply the only owner modifier to make sure that nobody else but the owner can call this. Because if they could, then anybody could just drain the smart contract of the funds, okay? So what we're going to do is transfer the Ether like this. There's multiple ways to send Ether around inside Solidity. This is the way that I prefer, is using the call function. So call just sends, a message to any arbitrary address on the blockchain, whether it's a smart contract address or an externally owned account like a user wallet. But what you can do is you can send in a message, but then you can send in the metadata, which is the amount of cryptocurrency that you're sending. So I'll break down call and what that looks like. So basically, call requires a recipient. In this case, it's the owner. You can do call, okay, to send a message. And you can just put in whatever, you can put in different data here. But right now, we're just going to leave this blank. We're just going to pass an empty string because we don't really want to send in anything with that. We just want to send cryptocurrency. And so we do that with the function, with the metadata. So kind of like we did up here with this value metadata inside JavaScript, we can do a similar type of thing inside Solidity. So just before the open and close parentheses, we can do open and close curly braces. All right. And then we can pass in value, which is the amount of cryptocurrency you want to send. All right. We basically just say address, this, So what is that? So this is the smart contract that we're coding inside of right now. All right, that's what this references to inside Solidity. We make sure it's cast to an address type. So it's going to get the address of the current smart contract. We don't know what this address is until it's deployed to the blockchain. So that's why we have to use this notation right here. And then we just get the balance. So basically it's saying, take the smart contract as an address, get the Ether balance, all right, and then use that as the amount of cryptocurrency that you're going to send in this line right here. So we're doing owner call with nothing, but that call is going to have a bunch of cryptocurrency, and it's going to be the exact amount of Ether that's currently stored in the smart contract balance. Okay, that's what owner call does. Now, call returns some arguments, and we can get reference to those. The first one is bool success. We don't care about the second one, so we should do comma and leave it blank. And then when we're done, we just say require success. And that's just going to make sure that this cryptocurrency was actually successfully transferred to the wallet. Otherwise, we don't want this function to actually operate. Okay. So I just reconstructed that, so I'm going to delete it, but that's everything that's happening here. All right. You could use the transfer function inside Solidity, but that's not the way I like to do it. I like to do it with call, just like this. Okay. All right. So let's do a test for this. I'm going to just use the test in the final coding solution. You can grab that from there if you'd like. All right. We're going to do describe withdrawing, and we're going to set this up. Basically, we're going to redo this test example right here, but enhance it. Basically, we're just going to store the ID of the occasion, the seat number, the amount. We're going to track the balance before. Inside the before each function, we're just going to get the balance before. All right, just to check what it is and compare it to the balance after. Basically, we're going to take a snapshot of this person's Ether balance, which really should be 0 before they withdraw the funds. Or not 0, it's going to be whatever it currently is, because inside Hardhat, you have cryptocurrency already in your account. But anyways, we mint an NFT, and then whenever that's done, we connect to the deployer's wallet and we call the withdraw function. And wait for that finish. And whenever it's done, it should update the owner balance, which basically says, hey, the balance after we did this transaction, it should be greater than the balance before. I'm not going to test for an exact number here because, again, whenever you are running the Hardhat blockchain, you get like 10,000 Ether, and the deployer has essentially been doing some transactions, so their balance is going to be decreased. It's hard for me to know exactly what that number is going to be, and all the Ether that's getting sent here. So all we're going to do is check for that it's going to be greater than the balance before. All right, and then lastly, we want to check that it updates the contract balance. So basically, whenever we call this function, it should give the Ether to the wallet of the developer or the deployer, but it should completely drain the smart contract balance. So basically, it should be 0. All right. So that's what we do. We check that the balance of the Ticketmaster address, which is the smart contract, okay, we expect that balance to equal exactly 0. All right. Run those tests, see if it passes. And boom, it passes. All right, so now we have completely coded out this smart contract for our app here. Okay, we've got the NFT contract that manages all the tickets. We've got everything on this back end that we need to start coding out the front end website. Now, we need to do just a little bit of housekeeping to prepare ourselves for building the front end. Up to this point, we've essentially just, coded out this smart contract with tests. We haven't actually put it on a blockchain yet. So that's what we need to go ahead and do. All right. So I'm going to show you in a new tab here how to start your blockchain with Hardhat. All right, we go to our tab here, and we are going to essentially just do npx Hardhat node. Okay, let me just try that again. So I made a typo here. I did Hardhat. If you've seen any of my other tutorials before, you've probably seen me make that typo at least once. I don't know why. I just forget that second H for some reason. But anyways, if you start it correctly with npx Hardhat node, you're going to see that a blockchain has started. Okay, it's going to give you 20 accounts. All right, starting with account 0 all the way through account 19, and they're each going to have account address and a private key, and they're each credited with 10,000 fake Ether. Now, don't get excited. This Ether's not worth anything in the real world. You didn't just instantly become a multimillionaire, okay? And also, I'll say, you should never use any of these accounts that I'm showing you on the screen to store any real cryptocurrency, because most of the time, whenever you start a Hardhat node like this, it's the same key pairs for everybody, basically the same private key, the same account address. So you can check that on your screen. Is your private key for account 0 the same as mine? Probably is, if you're using the same Hardhat version as me. So you never want to store any real cryptocurrency in any of these accounts, because your funds are going to get stolen. Okay. Same thing with the seed phrase. If you see the mnemonic seed for these accounts, you never want to use that to store any real cryptocurrency. All right. Just a word of caution there. But anyways, we have our blockchain running. Now what we want to do is take this smart contract that we just finished and put it on the blockchain. So what we're going to do is use this script inside of here. So go to scripts directory, deploy.js, and I've already created this script for you. I'm not going to code everything out from scratch here. I'll explain what it does. Okay, I want to kind of speed past this part so that we can get moving to the front-end application. Okay, so what this does is it executes code that's very similar to our Ticketmaster.js before function, where essentially we're just getting the accounts, we're getting the smart contracts, we're deploying them, putting them in the blockchain, and then we're doing these other things like, creating some occasions, and then, basically having stuff in our application that we can go ahead and use whenever we start the front end. So you could go through here in your MetaMask account, okay, and then create a bunch of occasions manually, but that's a real pain in the butt. I would rather do it with code. That's the whole benefit of code, is you can automate tasks that would take you a long time to do by hand. It's one big benefit of code, especially with scripting, and that's what we're going to do right here. So essentially, inside of our deploy script, we just set up the accounts and the variables. We just get the signers from Ethers, just like we did in our tests, like right here. Okay, get signers. And all we need in this case is just the deployer address. Okay. So we create the NFT name and symbol, Tokenmaster TM. We deploy the contract like this. We do get contract factory. That's the same line as this. Okay. And then we deploy the name and symbol. And then we wait for the contract to be deployed. And then we log to the console. Hey, it was deployed. Okay. Now we're going to get 6 different occasions so that we can sort of see the application, so that when we boot at the front end, we actually see some different, things here. And we're going to use the exact ones in the mock-up, like UFC Miami. The cost is going to be 3 Ether. The tickets is going to be 0. It's going to be sold out, basically. The date's going to be May 31st. Time is 6 p.m. Eastern Standard Time. So if you're watching this tutorial later, past these dates, you could change these. You could say, August 31st, for example. Okay. You can manipulate this date if you want to. I'd probably just run it the first time with the exact information in case you experience some bugs. You don't want to be trying to follow a tutorial where there's some discrepancies, but if you want to manipulate it later, that's how you can do it. So same thing with these other ones, ETH Tokyo. We've got 1, 2, 3, 4, 5 different events or occasions that we can buy tickets for. So then what we'd use is a for loop inside JavaScript, and we just create them one by one. So we just do Tokenmaster connect deployer. We call that list function that we created inside our smart contract right here. Sorry, this list function. All right. And we just list with the occasion name, cost, tickets, date, time, location. We wait for the transaction to get included into a block before we continue on to the next one. All right. And then we just log out of the console that it has created an occasion. Okay. So you should have that in your final project already. If you don't, you can just copy that from the final code solution from the GitHub repo. Okay. So now we've got our blockchain running, and we're going to deploy our contracts like this. We say npx npx hardhat run, do scripts, deploy.js, and do -- network localhost. Okay. And you can see it worked. So deploy the Tokenmaster contract with this address. We listed the event 1, UFC Miami, listed event 2, ETH Tokyo, Privacy Hackathon, Dallas Mavericks, ETH Global Toronto. So it was successful. Now, the final thing I want to do is save our smart contract information so we can start coding at the front end. This is really important that you do this whenever you're coding a front end app that's not totally aware of your Hardhat project. So inside of our project here, We have this source directory. That's where we're going to put the front-end application. We have this config.json, okay? This is where we're going to save the address of the smart contract that we just created. Now, you want to make sure that this smart contract address matches what's logged to the screen here. So the safe way to do this is just to copy it and then paste it inside of here, okay? Now, you can notice for me, it didn't change. Most of the time, Hardhat's going to generate the same address every single time for the first contract that's ever created. I have seen discrepancies from time to time. I'm not exactly sure why, but you just want to make sure that this address that's logged to the console is the same one that's inside your config.json here, okay? Now, the next thing that you want to do is take the smart contract ABI, okay? Go to the, let's just see here. Go to ABIs and see tokenmaster.json. We've already saved the tokenmaster.json ABI inside of here, but you want to make sure that it matches exactly what you just coded out in your application. So what's an ABI? Well, an ABI is really just a JSON representation of your smart contract, what the interface is like. So what are the function names like list, mint, et cetera, et cetera? What are the function arguments like, name, cost, max tickets, date, time? It's basically so you can create JavaScript versions of the smart contract when we code out the front-end application. And you want to make sure that this matches, what you just coded out, okay, in case there's any discrepancies. So if you ever make a code change to your smart contract, you need to update this, and you also need to make sure that this is the same, okay? So because your front-end application is not going to be aware of the changes that you made inside your Hardhat application, okay? I'll get to that when we start coding that out, but just make sure this is right. So you can find the ABI that's generated by Hardhat up here. You can go to the artifacts directory, go to contracts, and go to tokenmaster.sol, and look at tokenmaster.json. You can see what's in the ABI, okay, and minimize that, or just copy from line 5 to 582, and then go inside your tokenmaster, let's just see here, tokenmaster.json, and then just replace that with what you had inside of your build folder here. You want to make sure these things are in sync. Your app's not automatically going to sync these things up. You need to sync these things up manually. But once you've got that done and saved with the ABI correct and the address correct, you're ready to start coding out the front end. All right, so now let's start coding out the front end. All right, so we just did this, but in case you're skipping ahead to this section with the chapter markers down below or something like that, I just want to reiterate, up to this point, you should have your smart contracts already created inside this contracts directory. You can find the complete code solution if you want to there. You need to have your Hardhat node running. Okay, that's just with npx Hardhat node. And then finally, you want to make sure that your contracts are deployed to the network. Okay, that's with npx Hardhat run scripts deploy.js -- network localhost. And you want to make sure that this address right here matches exactly what's in your config.json here, okay, and that you have updated your ABI, okay, inside of the ABIs directory. All right, so we've done all this stuff, okay? So what I want to do now is, you can go back and check the last section. What I want to do now is head over to the app, and we're going to code out the application from scratch, all right? The front-end application, I should say. So what you're going to want to do is go to source app.js, all right? There's a lot of stuff in here, but we're going to initialize this. Basically, what we're going to do is we're going to leave all these imported files here at the top, but inside this app.js here, what we're going to do is take out all this stuff, okay? All right, we're going to just leave this return function here, and we're just going to keep a simple div, okay? And then we're going to put a h1 tag here. Okay, that just says hello world. All right, I'll come back and explain what this is here in a second. But for now, that's what we're going to do to just initialize the application. I'll even give you some space. So if you want to just, if you want to pause the video and copy this down, okay? Basically, just a quick summary. Don't touch anything up here. You just want to make this function that says app look exactly like this. All right. So I'll let you pause the video and copy that down if you want to. All right. So now what we're going to do is go ahead and boot up the front-end application. Okay. So if you go to your terminal, all right, make sure you got a separate terminal tab here. I'm just going to clear all this stuff out. we've got our blockchain running, and then we want to have a tab where we can still run terminal commands, but we want to have a separate one where we can run our web server, and we can run our web server just like this. We do npm run start, okay? And now you should see this web page automatically pop up in your browser just like this, okay? And you can see this text, hello world, which we just added a minute ago right here inside this app.js file. So let me quickly give you a tour of the front-end application, okay, and explain what we're doing here. So, we're working on the front-end side of things. And so if you're brand new, if you're not familiar with what front-end is and what back-end is, the front-end is what the user sees and interacts with on their web browser, okay? And the back-end is what's happening, in this case, on the blockchain with the smart contract. So the blockchain is the back-end with the smart contract. The front-end is the user-facing website that we're creating right now. Now, for web development, you use HTML, CSS, and JavaScript. But what we're going to do is use a JavaScript framework called React.js. If you're not familiar with it, that's what we're going to use. It's basically just a library for creating user interfaces. Okay, so basically you can write HTML and JavaScript all in the same place, and also CSS, all right, inside the same file, and mix them together. React just gives you a really nice way to do that, to make reusable components that are very modular. You can read more about it here. It's also got the React state object to do front-end data management, which we'll see here momentarily. All right. I use React in pretty much everything that I do on this channel and in some of my training materials. So just a quick introduction to that if you don't know already. It's widely used in the blockchain industry. Okay, so this is a React component. All right, this is the main component we're going to code inside of today. You can render sub-components, which you can see in this components thing, like the card, navigation, seat, etc., etc. We'll get to those one by one as we continue on the tutorial. But this is what a component looks like. Okay, you can see importing these other components and files at the top. You have this main function. We're going to use React functional components in this tutorial. So you should define a function called app. You can put a bunch of different JavaScript up here. But then inside this return, okay, this is where you actually put your HTML code that gets rendered onto the page. And you can also, evaluate JavaScript inside of it, which means that you can mix HTML and JavaScript inside the same code here by, doing that inside of these curly braces, which we'll see as we continue building this out. And then finally, you just need to export the function that you created here at the bottom, like export default app, and that's going to get, rendered to your browser. So one quick thing to mention here is that we are using CSS, all right? That's going to make our app look really nice. So we've already got the CSS written for you. We're not going to spend a lot of time on it. Again, here's our final mock-up that we're heading towards. You can see that we have an index.css file, which basically writes the CSS for the application. I'm not going to make you write all this in the tutorial. I want to focus on the blockchain development side of things. So when we start adding classes to our HTML, it's automatically going to absorb these styles that we've pre-generated, okay? And yeah, so normally I have this branch, zeroed out by the time we get here, but we'll just delete the code that's in the files and, write it as needed. So the first thing we want to do is connect our app to the blockchain. And actually say that before that, there's one prerequisite step. We have got, our website running, but you need to make sure that you got MetaMask connected to the correct network, okay? So the first thing you want to do is inside your MetaMask, all right? You're going to want to make sure you have the Hardhat network, okay? So by default, you're going to be on the Ethereum mainnet. You want to do add network, okay? It's going to take you to a page that looks like this. You just do add network manually. You can call it Hardhat. RPC URL, you got to go to your Hardhat node here, and you're going to see what's running on. Mine's running on this, so I would copy this, okay? And then for chain ID, you can get that from your config.json file here. You do this, all right? And then currency symbols, ETH, and then block explorer, you can leave it and click save. So I've already done this. It's not going to let me do it, all right? So it won't let me click save, but you can put all this information in there and click save, and it should create a Hardhat network for you. Whenever that's done, go back to your web browser here and then select the Hardhat network. You can search for it. Well, actually, you can't search. You can search for accounts. Click Hardhat, and then it should switch to the Hardhat network. Now, Obviously, a prerequisite for this is installing MetaMask. I don't really walk you through how to set that up. It's pretty straightforward. You can just Google it and look up the Google Chrome Web Store, or whatever browser you're using. But yeah, you need to have MetaMask installed. That's how you add the Hardhat network. That connects us to our development blockchain. Now, the other thing is you want to import the accounts that are coming in from Hardhat. So I'm just going to import the first or second account. I'll just do the first one for you. So what you're going to do is copy this private key, all right? And then you're going to go here and you're going to do import account. Let's see here. Import account, paste in the private key, click import, all right? I've already done it. It's not going to let me do it, okay? So I click cancel, but you could click save. You can switch to that. Go scroll down, find it, go ahead and switch to it. I've renamed mine, so you can go to account, let's just see here, account details, and then edit this. I just named mine to Hardhat 0. I call it 0 because Hardhat uses a 0-based index to name its accounts because they come in arrays, and that's the programming convention. So you can see account number 0 here, like account number 1. So the first one's 0, second one is 1, third one's 2, fourth one's 3, so on and so forth. There's 20, but you see the last one's number 19. So I just use the same naming convention inside my MetaMask to eliminate confusion. So like I just renamed this to Hardhat 0. You can repeat these steps for the first several accounts if you want to, 0, 1, 2, 3. And every time you boot up your Hardhat node, you should have the exact same accounts over and over again. That's the beauty of it. Then you can permanently have those saved inside your MetaMask. Now, one last thing that I would do while you're here is go ahead and reset your account. So go to go to settings, go to advanced, and do clear activity tab data. Okay, click clear. Because if you've done anything previously with those accounts, like you saw had some activity, you're going to get an issue with the cached nonce in your MetaMask. You might see some funny errors with that. So I'm not going to go in depth and explain that. Just make sure you do those steps right now, and you should be good to start developing and get MetaMask set up properly. All right, so now what we want to do is go ahead and connect our application to the blockchain. We'll do that by just checking our MetaMask account and showing on the page. That's a good, easy first step, okay? So what we're going to do is inside of our app, we're going to create a function here. So go inside this app function above the return right here, all right? And you are going to create a function called useEffect. So useEffect. All right, so this is a special function inside React, all right, that essentially gets run whenever the component like changes, okay? So if it receives some new data or something like that, new user interaction, then this is going to get run, okay? So this accepts two arguments. One is a function, a callback function, which basically gets run whenever, like you do stuff inside here, okay? Whenever you have useEffect run, like here's where your execution code goes, and then it takes a dependency array that it watches for things to change. Don't worry too much about this. In fact, I think we can probably get away with leaving it out if we wanted to, but let's just leave it for safekeeping. All right. So what I want to do here is go ahead and console.log. It's working. All right. And you can go back to your terminal, and you can do inspect. Okay, and you can see in your console, this statement here, it's working. All right, so you can see basically the useEffect function is run whenever it's run twice here because two different things happen inside the app. All right, so useEffect is wired up properly. Okay, so what I want to do here is actually speak to our blockchain side of things. Okay, the first easiest way to do that is to go ahead and get the account from MetaMask that we're connected with. Okay. So I'm going to do that like this. Basically, I'm going to use the code that MetaMask tells us to do this with, okay? Just above this, I'm going to do this. Await window.ethereum requests, and we're going to pass this in method eth request accounts, okay? So what is this? So basically, window.ethereum is something like window is the globally available variable inside JavaScript that is, it's just the window inside JavaScript. That's what it is. You can see window. It's got all this stuff on it. Okay. And we got window.ethereum. Okay. This is something that MetaMask attaches to your browser window so that you can talk to MetaMask. Okay. And so what you can do is window.ethereum, you can do make a request. This is an RPC request to your Hardhat node, basically. Request accounts, or this is an RPC calls, what I mean to say. This is the RPC method, method ETH request accounts. And what's going to do is return the current account that you're connected with MetaMask, so we can save it. Say const accounts. It's going to return an array, and then you can pass that array in right here. Okay. Okay, so I did realize it's not going to let me do that here. Can I do this? Let's see. Yeah, it won't let me do that. So let's do this instead, everybody. I tried to do this for simplicity's sake, but it's not. This was a failed strategy. So let's move this up into a new function. All right, we're going to do this function called load blockchain data. Okay, and we'll say async. All right, what we're going to do is take this async off. We're going to move this code up here, and I'm going to call load blockchain data. All right. So I tried to make it simple, everybody. Try to reduce the complexity, but that was a failed strategy, and this works now. Okay, so we can see our accounts logged to MetaMask. You can see it's just one account. That's the only one that's going to provide us because that's what we've connected with. And $17 million. It is logged to the console with an array. Okay, so just notice that. All right, so we add this load blockchain data function. I'll let you pause the video right now if you want to. Copy this down. All right, so next thing we want to do is show this account on the page. So in order to do that, we need to use the React state. So what is the React state? Well, essentially, it's like a front-end database for each component. So where if you want to take some data and save it inside the component so that you can use it in other places, that's what it's for. So for example, you can see like, you've got these videos, right? If you got 3 videos and you want to save that in your component, well, where does it go? Well, it might go in the component state, all right? And you want to see like, what's the status? Like, is this video liked or is it not? Well, you can write that to the component state as well, okay? Same thing like a to-do list. If you want to know where the to-do items are coming from, like the state is a really great place to put that. It's just where you can store data. Now we can put blockchain data in the state as well. That's exactly what we're going to do. So in this case, we're going to use the account for that. So we're going to use a function called useState. So we did use effect here, which basically is going to let us run stuff whenever our component changes. All right, that's imported from React to the top of our file. UseState is also imported. So what we can do is basically do this at the top of our app. We can do const account and set account equals useState null. So let's break that down. Let's start off with just useState. So this is a function that lets us, create a new piece of data that we want to track in the state. So we can do null, which can be the default value for this. All right. So if we get the data back from the state and it's not there, what should it return? Well, null. All right. And then it returns an array that we can do parallel assignment with, just like this. We can get the account that's actually in the state, and a function set account lets us write that information to the state. So I think it's best to just show this in action so that it makes more sense. Basically, this is going to be a function where we can write information. So we can do set account is equal accounts 0. That's the first account. So when I do set account, it's going to write the account to the state because this is a function. All right. I'm going to mirror this. And then account is going to be a variable that lets us access this. And we need this because we want to show the account on the page right here. So I can just do a paragraph tag and then just illustrate this concept. I think that'd make it more sense. Curly braces lets us evaluate JavaScript instead of our HTML code, like I was saying before, with the return. So I say account. Now if I go back to my website, you can see the account listed on the page right here. Okay. Awesome. So now we're cooking with gas. We're talking to the blockchain. We've got the account saved to the state and shown on the page. So while we're here, that should be good. One other thing I want to do is basically show you how to format this. So basically, I'm going to do accounts, and I'm going to do this additional formatting, which is this const account equals ethers utils get address. That's going to format the account for us. I believe it's going to convert it to checksum, give it to us in a string format so that it's nice. We can use it inside of our library. It's not going to throw any issues, and it looks nice on the page. Okay. And then I can do set account, and then just pass an account here. And then take this console log off. And then, boom, there you go. Now, one other thing here, I want to show you how to automatically refresh the page if you change accounts. So I'm going to switch to Hardhat 1. All right, if I change accounts, it still shows me my old account address on the page, and I have to refresh in order to see the new one. So how can we change that? Well, we can add this code to the page, okay? So I can just say like, fetch account. And then we can say refresh account. And put this code in here. All right. So what this does is we did a window Ethereum request, but now we can have events. So window Ethereum on accounts changed. We can pass an async function, and we just run this entire block of code basically again. I believe if you just copy this and like do Command D, it's not perfect. I'm trying to see what the discrepancy is. Maybe it's a spacing thing. I think it's a spacing thing, maybe. It basically does the same thing, okay? So this is the same code as this right here. So basically we're saying, you can even abstract this to a function if you wanted to and call the same function twice. I'm going to move this in a second. That's why I'm not doing it right now. So now if we go back here and we do Hardhat 0, we can see the account on the page changes. Awesome. Very cool. So now what I want to do is go ahead and inject that account into our ready-made nav bar component, okay? So I'm going to show you how to render a new navigation element onto the page. So our new component onto the page. At the bottom, I'm going to do some HTML here that says header. Okay. And then I'm going to do this H2 element here that looks like this. It just says header title, strong, okay, event, tickets, okay. And then you can see event tickets here. That's looking like this part of our mockup. And now we want to do is add this nav bar up here that shows our account, okay. So now we got some stuff coming up. Let's go ahead and add our nav bar, which you see right here, that will have the address in it. So I'm going to just go ahead and take the component that's imported from the top of the page here. So this navigation, if you go to components navigation, we'll just leave the code in there for now, okay? And I'm going to render it on the page. So how do I do that? Well, you do it, it's pretty easy. You do it like this. You just give it the component name, navigation, all right? But if you look at the file, it needs some other properties. It needs the account and it needs set account. So like we have a function called navigation, which I'll go over in a minute, but you can see that it has arguments, right? Our app doesn't have arguments. There's nothing in here, so we don't have to give this any arguments. But how do you pass in, where do you give it the account and set account? Well, you do it like this. You just do account equals account, and then set account equals this, set account, all right, and you click save, and you can see this account is coming from this, and the set account is coming from this, all right. And now if I save that, and I look at my web browser, you can see that, if I close this, you can see that our nav bar looks exactly like our mockup. All right, it works. Okay. And now what I want to do here is take out one last thing, is this fetch accounts. I want to take this out because if you notice, whenever I refresh the page, this thing says connect, and then it automatically connects for us. We actually want the user to consent to give the account to the application. So if I take out this fetch account block here inside low blockchain data to where it just looks like this. Now I see this connect button, okay? And if I click it, it actually requests the account from MetaMask and it shows it on the page. But if I load it, you don't automatically have your wallet, okay? If I go to like Hardhat number 7 or something, you should see what it looks like. See Hardhat. Let's look at Hardhat number 5. Okay, so if I just refresh here and do connect, now it should, let's just do Hardhat 5. Let's do 5. Okay, so it's not connected. Let's refresh and see what happens. Click connect, and then you want to make sure you're on this one. Yeah, okay, awesome. Okay, awesome. Now you can see that this comes out. So where does that come from? How does that button click work? Well, again, I'm not going to code out the entire navigation component from scratch. But what it does is inside of here, you've got this button here to connect. It has an on-click handler, which basically means when you click this button, run this function. Okay, and it has a connect handler, which basically does exactly what we just did. Okay, in this app.js load blockchain data function that I just took out. It just does the wait for the accounts and then, set account. And then we're already reading account here. And then we're just showing the account on the page. Also notice that we are truncating the account so it doesn't flow off the page. We just take the first several characters. We include an ellipsis, and then use the last several characters to show the shortened version so it doesn't just run off the page. Okay. And then we've got the other basic markup inside of here. Now, let's see here. That should be pretty much everything that we need for the initial account setup. All right, so now let's go ahead and load the smart contract into the application. Okay, so the first step is going to be to get our actual MetaMask connection loaded into our project so that we can create an Ethers.js provider. Okay, so we already have a MetaMask connection with window.ethereum like we talked about. What we want to do is create a full-on Ethers.js connection, which is called an Ethers.js provider. It's the thing that provides the connection to the blockchain to your application. It's what turns your app into a blockchain app. And we can do that, with the Ethers library we've imported here. And we can use the window.ethereum object from MetaMask like we showed a minute ago. So how you create a new Ethers provider is like this, okay? Let's just see here, like this. Say const provider equals new Ethers providers, Web3 provider, because we're using Web3 provider for MetaMask, and we just add that window.ethereum object from MetaMask that we've been using, okay? And again, this is your new blockchain connection. This is what provides the blockchain connection so you can sign transactions with MetaMask, all that type of stuff. And we want to save it to our state, just like we do with our account here, okay? So what we're going to do is do this at the top of our file, provider and set provider. And then we're going to set the provider right here. And we're going to use this in many other components down the road. Now, let's just see here. What we want to do is now create a connection for the smart contract. Let's look at the Ethers documentation to show you how to do that. So you can see inside the Ethers contract, this is all you have to do to create a JavaScript version of your contract. Do new Ethers contract, and then you need a few different ingredients. Number one is the address of the deployed smart contract, the ABI of the smart contract, and then the signer or provider. Okay, so let's show you how to do that. So basically, you can do new Ethers contract, just like from the documentation. Okay. And then you can pass in the address. I'm going to hard code this for now. You can find your address inside your config.json file. Okay, so I'm just going to hard code it for now. And then let's see here, the ABI. Let's just say, let's just leave that blank for now. And then the signer or provider. Okay, so we're going to use a provider, and we just got the provider here. Again, that's going to wire the contract with the blockchain. Just say const Ticketmaster. Okay. And then let's get the ABI. So I'm going to literally show you the quick and dirty way to do this. And then we'll refactor it. But you could go to your ABIs directory here and then just copy this and then you can like just like put it in here. I'm gonna make it very, very simple and dirty, just so that you see how it works, and then we'll refactor it. You can literally just like put it right here. It's like really terrible code. But then after this, what I'm gonna do, you don't even have to do that step. I'm just gonna show you on screen. Console.log token master.address. Okay. So let's just save that and go to our app here, and then token master not defined. Hold on, let me just copy it. Token master, probably capital M. Okay, if I go to my console, I can see token master address was logged here. Okay, so now we have actually created a JavaScript version of the smart contract. Okay, I want to show you that it happens. Now, if you didn't catch all that really fast, it's okay. This is terrible code. I would obviously never do this in the real world, but I want to show you where those ingredients are very literally so that you can see like what's being put in there. All right. But now let's refactor it. Let's go ahead and delete this nasty mess. We don't want to actually get the ABI that way. That's really, really terrible. All right. So I'm going to delete all that. But I wanted to show you how it works. And so we're going to put in the ABI. So where does it come from? Well, we've imported it, right? So ABI is right here on line 10. Import token master. All right. So I can just copy this and then paste it in, replace it. If I go back to my app, it still works. Okay, so we know it works. It's getting the ABI from the right place. What about the address? Well, the provider we don't need to change. We know it works. It doesn't need to change. As terms of the address, where can that come from? Well, if you look at our config file, we just read that address from here. But what you can do is actually read this. So we can do this. We can do, we can get, say, const address equals this. We can say ethers, hold on, say config. We can paste in this network ID. I think it's actually going to be a number like this. And then do token master. Okay, and then replace this address here. Let's see if that works. All right, it's still working. Awesome. So again, what I did here is I'm reading for this config file, which is imported here. All right, and then I'm reading, I get to dig into this thing, right? Here's a network ID, and then it's got the token master key and the address key. So I go boom, boom, boom. So I read boom, boom, boom. All right, and that gives me the address here, and then I just pass that along. Now, finally, this is the network for Hardhat, but what if we change networks, right? What if we deploy this thing to a different network? We want the network to change every time we change our network in MetaMask. So you can do get network, all right? You can basically do this, const get network. I'll console log that. Okay, network equals await provider get network. We already got the Ethers provider. You can see it's right here. Chain ID 31337. That matches exactly what's in here, 31337. So we can do network dot chain ID, and then go back to our app here, and it still works. Okay. We can take out this console log, and then yeah, we can just put this right here. Okay, and then that looks a lot better than our nasty mess that we had, a minute ago. And then finally, what we're going to do is do token master and set token master from our use state. And then we're going to set token master right here. We want to save token master to the state. Okay. And we still can log token master address, and it looks right. Awesome. So we've loaded our smart contract up into our application. This is awesome. We're connected to the blockchain. We got the smart contract loaded up. Now we want to call the smart contract functions to start listing out some data on the page. Okay. So what we're going to do is go ahead and load up all the occasions. So if I go to token master.sol, you can see we have this occasions here. Okay. And we got the total occasions, which is this right here. Because what we're going to do first is essentially list out all of these on the page. So the first thing I'm going to do is get this count, this total occasions count, okay? And we're going to talk to the smart contract and make sure we can get that number back correctly. So we're going to put this line in here. Const total occasions equals await token master, call the total occasions function, and we're going to console log it. I'm going to show you a trick. You can do open close curly braces and do total occasions. And it will give you a key and value of the same name so that you can read it easier in your console. So let's look here. You can see total occasions is big number. Let's do, I tried to give you a shortcut. That's not really going to work because we need to call toString on this. toString. All right, total occasions is 5. Awesome. So that is working properly. Okay. So let's take that out. We've got 5 occasions in our smart contract. That is great because inside of our deployment script, we did 6 events. I'm not sure why the last one didn't get in there. Well, we'll see what the issue is, but that's okay. Close enough. So yeah, we've got some occasions in there. Let's go ahead and list them out onto the page. Well, actually, before this on the page, we had to load up all the occasions. This just gave us the total number. So now what we need to do, now that we know how many there are, we need to go into our smart contract and call each one of these. We need to go in and say get occasion and pass in the ID and then actually return it because all we're doing right now is getting the count, but we know how many to get. So what we can do is use a for loop and access each one individually. The first thing we want to do is create an array for this. Say const occasions equals empty array. And then we want to do this. So this is a for loop in JavaScript. Basically, this is a code that runs until you tell it to stop. So we start off with a counter, I equals 1. And then we basically say, as long as I is less than or equal to, the total occasions number, which we saw was just 5, then go ahead and run this code inside the loop and then add 1 each time. So the first time it runs, I will be 1. Second time, I will be 2. Third time, I will be 3. And as soon as it is, 6, it's going to stop and not work anymore. So what we do is say const occasion equals await token master get occasion. Okay, we're going to call this function right here individually inside Solidity get occasion. Get that information back, and we're going to save it to this array which we just created. And then finally, we're going to save that entire array here. Okay, so we can use inside the app. Let's do get occasions, set occasions up here. All right, just below token master occasions, set occasions. We're going to do the same thing right here. Okay, and finally, we're going to console log instead of token master address. We're going to console log occasions. All right, save that. Go back to our browser, refresh the page. And we can see we got some occasions here, right? Awesome. Very cool. So we got some duplication. We can fix that. But we do see that we've got pretty close to the expected result loaded up into our app here. Awesome. All right. So what we're going to do is we're going to go ahead and show those occasions on the page. Okay. So just below this, I'm going to go ahead and get rid of this account. We don't need that anymore. We can get rid of the hello world. That was all just placeholder stuff. What we want to do is go ahead and put in this div right here. So div class name cards. Okay. And inside of here, let's just go ahead and refresh our page, make sure everything looks right. Okay, I can kill this. We don't need it. What I'm going to do is loop through all of these occasions in this array that we just created and show them on the page. So I'm going to create a mapping function inside of JavaScript right here. Okay. So just like this. All right. So we're going to read the occasions here and call map. So map's a function you can call in an array. And it has it accepts a iterator function, which is going to have 2 arguments. One's the occasion itself, so we can access each occasion as we loop over it in the array. Also the index, which is just the position of the item in the array, or the occasion in this case. Right now, we're just going to say, we're going to do a little paragraph tag just as a placeholder, and say occasion. Sorry, I spelling it. Spelling is terrible. Okay, all right. So now you can see an occasion is shown on the page. So each have a unique key property. You're going to see this key equals. This is a thing with React where it wants each element to have a unique index. That's why we use index here. So we use key index. Okay. Okay, so you can see the occasion on the page. Obviously, it doesn't have any data about the occasion, but you can do you can use JavaScript inside of here and just do occasion.name. All right, and there we go. We've also got some duplication. We'll fix that here in a second, but you can see all of the data for the occasion getting listed on the page. Okay, so I found this source of the duplication. This is my fault, everybody. I made a typo here. So I can see Castians. I just accused myself of being a horrible speller. I know that's not how you spell occasions, not even close. So it's just a mistake. Just a typo. So take that out. Make sure this is spelled the same as all the other ones. So what you're doing here is you're overwriting the occasions every single time, and you're fetching the fresh ones from the blockchain here, and you're saving it to the state. So I was just continuously adding them to the page every single time we refresh. Okay, so that list would keep growing and growing. So this should be fixed. And now if I go back here, I can see that there's the exact number of occasions that I expect to see on the page. So 5 here and 5 here. All right, so now let's make this actually look like something, okay? So what I'm going to do is replace these with the actual component that you're going to see in your final code solution here. We're going to use the card component, which you can see over here. We've imported it at the top of our file. We're going to go ahead and just pap that bad boy in there. All right. And then we need some other dependencies. So we've got the occasion. We've got the ID. We basically take the index and we add 1. Okay. Tokenmaster, we've already set that. Provider, we've set that. Account, set that. Now, toggle is a new thing that we're going to use later. A toggle, set toggle. Okay. And then set occasion. And then, yeah, let's just go ahead and add these things right now. These are just going to be something that we add to the top here. So basically, we'll just do these 2 new use state functions like this. We'll do occasion, set occasion. Use state, we'll do empty object here. And then toggle, set toggle. We'll come back to this. Don't worry about it for now. It's just going to be whenever we click some buttons in our components, but just know that we need it in order to render this one. Okay. So now we have shown that on the card component, and let's go back to our page. Again, we've already got the card component code filled out. We'll explain how that works in a second, but let's go to our page and we can see, boom, we have got some events on the page. Okay, UFC Miami, Tokyo, etc., etc. So we can see what's inside the card component. Basically, we just take all these dependencies that we just injected. We've got some basic markup that just shows the occasion date. That's what you can see here. All right, the occasion time, obviously that's what you can see here. The occasion name and the location. Here's the name, location. The cost, we get the occasion cost as string. We format it into Ether like this. Okay, 3.0 ETH. And then we have this button. Okay, so basically if the tickets are equal to 0, if there's no tickets left, we show sold out, which is this red button right here. And if there are seats available, we do view seats. This is a button that you can click. Okay, when you click this button, what's it do? It does toggle pop. Okay, so that does this toggle pop. We do set occasion. It basically just fetches the current occasion out of the state. All right, and then, or sets it to the state. And this toggle, we do set toggle, true or false. And that is going to set this toggle that we just created a second ago. What that toggle is going to do is going to let us open up our seating map so we can pick the, it's going to open up a pop-up. That's what toggle pop means. And we can show the pop-up to actually fetch the seating chart. Okay. So that's pretty much it. Now, the last thing I want to do here is basically add more piece of markup onto the page before we continue on. That's going to be the sort component. So just below the header, we're going to pass top, do this sort, and that's going to show this sort right here on the page. Okay, these don't really work. That's just sort of for UI purposes, just to make it look nice. You could wire these up if you really wanted to. Same thing with the search box up here. It doesn't do anything, but if you wanted to, wire this up, you definitely could. But all the blockchain stuff is definitely working 100%. All right, so now the last thing that we're going to do is add the ability to purchase, tickets. So right now our mockup looks pretty darn close to the screenshot. It's actually pixel perfect. I'm toggling back and forth between the two in my browser. You can see this is the website, this is the mockup, and nothing changes. Now the mockup's a little more low resolution, okay? So you can kind of see it gets lossy. This one's much sharper. Obviously the address is changing because I had different accounts connected, but otherwise it's pixel perfect. So we're doing a good job here. Okay, so what we want to do is actually click on one of these buttons and we want to make the seat pop up. So what we do down here into the app.js is we're going to check to see if that toggle has been set. So you're going to toggle. Okay, we want to make sure it's true. And if it is true, we want to render the seat chart. Okay, so you can grab this from the final code solution if you want to, but basically we've got this seat chart right here component, and we're going to render it on the page just like this. Oops, sorry, don't want that whole thing. We just coded that just like this. Okay, so that's just the seat chart component. We give it the occasion that's been set from the previous component, the Tokenmaster smart contract, the provider, and set toggle, which we have also passed into this component. So that's going to let us close the seat chart. Okay. And if I go back to my thing here, now I can see the map. All right. So if I click refresh and I click view seats, that toggles it here. If I click this, it goes away. So let's look inside the seat chart component. So basically, let's look at the toggle pop. You can see basically this button here, the X button. So set toggle false. So on click close, it's just a button. All right, Alt close. That's just what is the CSS for this X button. Okay, that's where it works. On click set toggle false. That's the toggle here that makes it open and close. All right. All right. And so on the seat map, of course, we have the occasion name. We've got some basic, we've got the X button here that closes the thing. We've got the basic stage here. And then we show all the seats taken. We compute those. We get the seats taken and we give it an array. We fill in these and we show a seat for the seat component. That's this nice little mock-up here that just has a button on it that we can click it to pick the seat. All right. And we set the, go back to the seat chart. We compute them and show them on the page. The step, the column start, max columns, row start, max rows. Seat taken, is it true or false? The buy handler, and this. So whenever we buy a seat, let's just go ahead and do one. Let's go ahead and buy a seat. We'll see that it goes away. All right, and we should confirm with MetaMask. All right, and now we can see it grays out. All right, another one, and it's going to make it go away. And so you can see it actually turns gray, which is pretty cool. All right. Then we have walkway, all right, which is the delineation. All right, basically we got 25 seats over here. We've got, 175 minus 25, so 150 seats here. And then also another 25 seats here. So a walkway and then walkway. It's pretty cool how it's laid out on the app. You can go buy seat 193. If you do, it completely goes away. All right, so it's pretty awesome. You can go through and manually buy them all if you want to. And yeah, it works. So that's how we render the seats on the page. Now, what I want to do is actually code out the buy handler with you. So I'm going to take this out. We're going to code this out. So find this thing called buy handler, because I want to concentrate on this code because it's important to understand how this works in order to understand how to sign transactions with MetaMask on the blockchain. So basically, you can see this buy handler for the seat. All right, inside the seat, anytime you click one, you see this on click, this buy handler. What it does is anytime you click a seat, this runs. It calls this function buy handler and just passes in the seat ID. Okay, and then that buy handler, is passed in here and it gets called here, and then you just pass in the seat number. So what we want to do here is first, let's just see here. We want to say set has sold false. So set has sold is just going to tell us whether the seat has been purchased or not. And then we want to buy the seat. And then we want to set has sold to true. So once we've purchased it, we want to set household to true. So how do you, do a purchase? Okay, so it's just like we did in our tests. So if you go back here and then you look at our tests, you Tokenmaster test. We need a signer, so we need to get signers with Ethers just like this. Okay, so we get the signer from MetaMask. We just say const signer equals await provider get signer. All right, that's the signer. That's our MetaMask account, so that we can get a signer just like we did here in our tests. And then we need to do like for minting, we need to do Tokenmaster connect, pass in the signer, and then call the mint function with all the information that it needs. Okay, so we can do that just like this, and then basically do transaction await. So basically, you could copy this from the test and put it in here. And then once you've seen how to do it before, you just modify it, all right, and then fill in all the necessary variables. And that's exactly what I'll do right now. This is not going to work by itself, but if we fill in the right information, then it will. So here's what the right information is. Basically, Tokenmaster connect signer, which we just got here from MetaMask, call the mint function, get the occasion.id. Okay, occasion comes from the state, what we just passed in up here, .id. The seat, which comes from this function right here. And then the amount of cryptocurrency value is the occasion.cost. You do transaction wait, and it will work. Go to our terminal here. Let's go to a different event. Let's go to the ETH Global Hackathon. Let's buy seat 80. MetaMask confirmation pops up. Confirm. And boom, it's gray. Goes away. Awesome. We're cooking with gas. All right, so that's an overview of how to create a blockchain-based Ticketmaster clone with Solidity, with JavaScript, with React.js, full stack, smart contracts website, and everything. So from here, what can you do? Well, you can definitely add more features to this project if you want to. You can take your application and put it out there on a blockchain, put your website live out there on the web. You can use it for a portfolio. Or if you want to take the next step and really double down on your coding skills and create a professional level application that's fully featured, ready to go, then I can show you how to do that over at dappuniversity.com/bootcamp. All right, I can also show you how to increase your salary well past 100K, break into the blockchain industry. You really don't have to be an expert to get started today. I've helped people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.